Okay, so hi everybody, welcome to class today. We're going to be talking about a few calculations that we didn't get to last semester, so that's where we're going to pick it up with today. We're going to start with percent composition. This should be a pretty easy idea to take a look at. So basically it's going to be the percent of the elements that you find inside a chemical formula. So we're going to have 3 steps, and you should write these in your notes. The title, again, should be percent composition. And for your 3 bullet points for your notes, you should find the mass of each element in the compound. And remember, we're going to look up the masses of each element on the periodic table, and we're going to multiply our masses by their subscripts. The subscripts are going to be very important. They're going to tell us how many to multiply each mass by. Then we're going to add all those together and divide by the total mass of the compound, and that's going to give us the percent when we multiply by 100. So let's take a look first at the at some example of this. So if we take an example of copper 1 sulfide, this is copper 1 sulfide. Now, how did I know that was copper 1 sulfide, just to remind everybody? Well, if I were to crisscross or uncrisscross these subscripts, I would find that, in fact, I have a copper 1, not a copper 2, so my Roman numeral is a 1, and this would be sulfide. Now, why is it not sulfate? Because it doesn't have any other nonmetals like oxygen. It is just a single nonmetal, so I have it ending in IDE. So the question is, what percent of copper is in this compound? And so when I look at this compound, and I'm going to erase this name here so you can see this compound again. When I look at this compound, I can see that I have 2 coppers, so I'm going to multiply copper's atomic mass by 2. And that gives me 127.1. And I'm going to multiply sulfur's atomic mass by 1, because there is only 1 sulfur in this compound. And that gives me 32.7. And that gives me the overall molar mass. Remember, everybody, this is the molar mass of the compound. Molar mass of 159.17 grams. And this unit label is really correctly written as grams per mole. Then, to find my percent, I'm going to multiply or divide, copper's atomic molar mass, so 2 times 63.55, so I have 127.1 divided by 59.7, and that should give me an answer, and it doesn't look like I wrote down the answer here, so let me pause real quick and get you that answer. Okay, so when I do the math, I'm going to remember to multiply this by 100, and when I do the math, I get 79.9% of this is copper. That means the other 20.1% will be represented by the sulfur. But this question was really only asking what percent of copper is in this compound. Okay, so putting that to immediate use, we're going to go see if we can do some practice of calculating molar mass and percent composition. And so this is also linked in your directions for the Canvas class. And I'm also going to have this printed for you so that you have it in class with you so you can do this on paper. So much easier to do this on paper. So let's take a look at the directions. It says, complete the following problems and shade in the correct answers on the grid. All molar masses will be rounded to the nearest whole number. All percent compositions will be rounded to the 10th place. So these are your possible answers right here. And so if we say something is a correct answer, then we would be saying, oh, okay, so that's a correct answer, so we're going to shade that in. But as you can tell, I haven't done any calculations yet, so I don't know if I have a correct answer there or not. So let's look at our first couple of questions here. Our first question says, determine the number of moles of H in NH4 parentheses 2 CrO4 and determine the number of moles of N. So literally speaking, it's asking you how many H's are there in a compound like this, and how many N's are there. And we have to keep in mind that what we actually have is a 2 right there on the outside of the parentheses. And we need to remember that the 2 distributes itself not only to the N, but also to the H as well. So if I were saying this, I would say that there has to be a number of 8 H's and there has to be a number of 2 N's. And so that one was a pretty easy one, but that means that I can go and I can shade in the 2 right here, and I can shade in the 8 right here. And so I've got those 2 answers. But let's look at one that's actually a percent composition sort of question. And so I have Ag2SO4 right here. And the first thing I need to do is I need to calculate a molar mass. So I'm going to use my periodic table for that. Okay, so I go and I find my periodic table. So here's a copy of my periodic table. And the first thing that I'm going to need to do is find the molar mass of Ag. So here's Ag right here. And I can see the molar mass is 107.868. And I've got S and O4. And then there's O right there. So those are my molar masses I'm going to use. And the directions already told me that I need to use whole numbers. So for Ag, I'm going to use 108 because 107.868 rounds to that whole number. For oxygen, I'm going to use 16. And for sulfur, I'm going to use 32. Okay, so once I know all of that, I can go back to my page, and I can take a look at Ag2SO4. And so the first thing that I'm going to do is I'm going to say, okay, I have 2 times 108 for the Ag that we just got off the periodic table. And I'm going to add that to 1 sulfur, which we said we were going to use 32. And I'm going to add that to 4 because I have 4 oxygens times 16. And so when I add that all up, I will be able to tell what is my molar mass. And so, okay, so when I add that all up, 2 times 108 plus 32 plus 4 times 16, I get 312. And that's my molar mass right there. That goes right there. That's my molar mass. And I'm going to be able to shade in 312. Remember, previously I had shaded in a 2 and I had shaded in an 8 there. So now I'm ready to move on to percent composition of the Ag. And to get just the percent composition of the Ag, I need to take the part that is the Ag. So this is the part that was the Ag, and I need to divide it by the 312. So that means I have 2 times 108, and I'm going to divide that by 312, and I'm going to remember to multiply that whole thing by 100. So when I get that, I will have my percent composition of Ag. Okay, so when I do that, I come out with 69.2%. And that can be recorded right here for my percentage of Ag. And that means that I get to shade in this part right here. And I'm going to continue this with sulfur next. So for sulfur, I am going to take the part that was sulfur, which was 32, and I'm going to divide it by 312, and I'm going to multiply the whole thing by 100 to make it a percent. So 32 divided by 312 gives me 10.3% for my sulfur, and I can go find 10.3% right here on my chart, and I can shade that in as well. Now, there's a couple ways to finish up this calculation. If I feel like I've done a good job and I've got 69.2% for the silver and I've got the 10.3 for the sulfur, then all I have to do is subtract this from 100. So 100 minus 69.2 minus 10.3. 0.3, and that will tell me how many, what percent of oxygen I have remaining. So 100 minus 69.2 minus 10.3, and my final result should come out with 20.5. And then I can go shade in 20.5 right here as well. Okay, so your job is to, of course, finish the rest of these calculations on this page. So you have this part here, and you have these parts here. But you'll notice down here at the bottom, there's a couple of other questions that I would like you to get to. So that means that we need to go back to our presentation and make sure that you know how to do and what is an empirical versus a molecular formula. So let's take a look at the next part. Empirical versus molecular formulas. Okay, so in your notes, you're going to want to write down that an empirical formula is the smallest whole number ratio of the elements in a compound. We have already talked about reduced formulas, and so that is the empirical formula. An empirical formula is a formula that cannot be reduced anymore, whereas you're going to see that a molecular formula is actually the actual or the exact formula, and it is not the simplest whole number ratio. So you can see that in this example as well. Both of these terms need to be written into your notes. Pause this video if you need to pause and write those two terms. Okay, so how do we find a molecular formula? To find the molecular formula, you will compare the molecular formula mass to the empirical formula mass. So we are going to take the molecular formula mass and we're going to divide it by the empirical formula mass. This will give us the factor that that is the multiplying factor, the factor that is going to increase the empirical formula back up to its molecular formula. So let's take a look at an example of this so you can see what this looks like. So steps for writing molecular formulas. We're going to calculate the molar mass of the empirical formula. We've done that before. We'll practice it again. We're going to divide the formula mass by the empirical formula. This means we're going to actually have the larger number on top, the smaller number on the bottom. And then we're going to multiply the empirical formula by this number so that we can calculate the new molecular formula. So let's take a look at our example here. It says determine the molecular formula of the compound with an empirical formula of CH and a formula mass of 78.110. So I can tell by figuring out the formula mass of the CH. Now you might wonder, well, how do we figure out the formula mass of the CH? So let's remind you that from the periodic table, the C has a formula mass of 12.01 and the H has a formula mass of 1.008. And so when we add those together, that's where that formula mass of the empirical formula came from. So that's the empirical formula mass. So notice what we're doing. We're dividing the number given in the problem by the empirical formula, and we find out what our factor is. Our factor is a 6. So we're going to multiply that 6 by the CH. So our molecular formula comes out to C6H6. So what are we going to do with this information? I would like you to try, please. Let me get rid of this stuff. I'd like you to try that yourself on these last two problems. It says if the molecular formula of this compound, NS, has a molar mass of 92 grams per mole, what is the molecular formula? What is this molecular formula? And then you're going to repeat that again for a compound described in number 5. So that is your work for today, everybody. I am sorry that I'm not there today. I hope I'm going to be able to be there in class next time. Please send me any emails you have if you'd like to ask me any questions. Otherwise, have a great day, everybody. Bye-bye.